Halogens. So, the melting points of the halogens. The melting points of halogens increase going down the group. So this means fluorine has a lower melting point than chlorine, and iodine has the highest melting point of these four halogens. And this is because in the diatomic molecules that the halogens form, because they are made of the same atoms, they have the same electronegativity. So this means that each atom attracts the bonding electrons equally. So it forms an instantaneous dipole, which means that the electrons are constantly moving. So at any moment in time, the electrons could be closer to one atom or the other, causing charges to be made in the molecule. And these instantaneous dipoles form instantaneous induced dipoles, which are the interactions between the diatomic molecules. So this means that the instantaneous dipole on one fluorine molecule, for example, would cause an induced dipole on another fluorine molecule because it either attracts or repels its electrons. And this is important because going down the group, the number of electrons increases, and this increases the charge differential. So the charges on the molecules in the instantaneous induced dipole interactions will be larger. And this is important because this means the strength of the intermolecular forces increases going down the group. So this means that there is increased amount of energy needed to overcome the attractions between the molecules, meaning as you go down the group, there are higher melting points. Next is bond enthalpy. Now, bond enthalpy is the energy required to break bonds, and it is measured in kilojoules per mole. And so after chlorine, bond enthalpy in group 7 decreases, as you can see here. And this is because the number of energy levels increases as you go down the group. And of course, this increases the atomic radii. And as the atomic radii increases, this means that the atoms cannot get close enough together. And this is because, of course, the atomic radii increases with the energy levels. And as the atoms cannot get close enough together, the bond is stretched out and strained. So the bond is larger. And this means that less energy is required to overcome this stretched and strained bond. Though there is an exception, and fluorine is the exception. And fluorine, this is because their atoms have a much smaller radii. So this means that the atoms can get very close together. The bonding electrons in the diatomic molecule, covalently bonded, repel the lone electrons on the fluorine atoms because they get so close together. So these bonding electrons are able to repel the lone electrons on the fluorines. And this repulsion is greater than the attraction between the bonding electrons and the positive nuclei in the covalent bond. And because this repulsion is stronger than the attraction, the atoms are pushed apart. So the fluorines are pushed apart, stretching and straining the bond even more. And this means that less energy is required to overcome this bond because the bond is stretched out and strained because of the repulsion. And this means that fluorine has a lower bond enthalpy, making it an exception to this pattern. Lastly, we're just going to talk about oxidative power. So firstly, oxidation. Oxidation is the loss of electrons. And reduction is the opposite. It is the gaining of electrons. The oxidizing agent is a substance that gains electrons, itself being reduced in order to oxidize another substance. So an oxidizing agent oxidizes another substance by itself being reduced. A reducing agent is the opposite. A reducing agent loses electrons, being oxidized itself in order to reduce another substance. So to reduce another substance, a reducing agent is oxidized. And this brings us to oxidative power. Now, oxidative power is how readily the substance accepts electrons from another substance. Sorry about that. So oxidative power in a displacement reaction means that chlorine displaces bromine in the potassium compound because chlorine has a higher oxidative power, meaning it is able to take the electrons from the bromine and displace it in this compound. And this is a redox reaction because both reduction and oxidation are occurring. So redox reactions aren't about how reactive the compounds are or the elements, it's about their oxidative power and how readily they take away and accept electrons.